So this video is about a transformation called rotations. You guys should be familiar with rotations. Think about like planets rotating the sun. The sun in that scenario would be the center of rotation. And so when we rotate on a coordinate grid, you need a couple things. The first thing that you need is a point of rotation. That's the point at which you're going to rotate around, like how the planets rotate around the sun. Oftentimes we rotate around the origin in the coordinate grid, but that's not always the case. I could rotate around the point 4 or 3 if I wanted to. And you also need an angle at which to rotate, because there's a difference in rotating just like 1 degree versus rotating like a full 360, which would actually get you back to where you started, or rotating like 90 degrees or 180 degrees. You also need to know the direction at which you're going to rotate. So are you going to go clockwise or counterclockwise? Sometimes a problem will just say clockwise or counterclockwise. But another way we might denote that is we denote a counterclockwise rotation with a positive angle. And a clockwise rotation is negative. What I mean by that is, if I were to rotate this point right here, positive 90 degrees, that would land me here. This would be positive 90 degrees. If I were to, because that was counterclockwise, so it's a positive value. If I were to go clockwise, we would call that negative 90 degrees. So I know that that's a little counterintuitive, that clockwise is actually negative, counterclockwise is positive. You'll see why this is the case a little more in pre-calc. Also, just for the record, it follows the quadrant order. It goes quadrant 1, 2, 3, 4. That's why counterclockwise is positive. And if we go backwards, it's negative. Just so you know, if I were to rotate a positive 270, positive 270 degrees is the same thing as a negative 90, or vice versa. Negative 270 is the same as positive 90. So there's lots of ways to do these rotations. If I wanted to describe this rotation here, it looks like we rotated 90 degrees in that direction. That is a clockwise rotation, so it should be a negative number. So I'll say negative 90 degree rotation. You could also say a clockwise 90 degree rotation. And it looks like the center of rotation was that point right there. I'm going to ignore that for now. This one was 90 degrees, but in the other direction. It went like this, because now it's kind of laying on its back. So this one, I would say, is a positive 90 degree rotation. Or you could say rotated 90 degrees counterclockwise. Or you could say a negative 270 degree rotation, if you really feel like it. This one rotated all the way around till it was upside down, and so that one is 180 degree rotation. I could have put negative 180 degrees, but that's actually just the same thing. If you go clockwise or counterclockwise, you're gonna get the same thing if you go 180. All right, so let's do a couple more examples here. If I want to describe this transformation, the original was this one. That's the preimage. The image is the one with the little primes. And so I can tell that S went all the way over to the opposite quadrant. Same thing with C, same thing with R. That means this was probably a 180 degree rotation. Like, see how R was on the axis and it went all the way over to this other side of the axis. So this was a 180 degree rotation, and the origin was the center of rotation. So just to be specific here, I'm going to say about the origin, or around the origin. So you need to denote the angle of rotation and the point of rotation. And in this case, it didn't matter if it was positive or negative. On this one, it's important which is your pre-image and which is the image, the new one, because that's going to impact the direction you go. So on this one, this is my pre-image, this is my new image, because it's got little primes on it, if you can see that in the video, hopefully. So notice that I went from X to X prime, N to N prime, B to B prime. It looks like it swung in this direction, again, kind of about the origin. It's like it took it and swung it and made this new shape. And so what happened there is it went counterclockwise, meaning it is a positive 90-degree rotation about the origin, or you could say around the origin. I can tell because B is in pretty much the same spot, but in a new quadrant. Same thing with X, same thing with N. Okay, so let's try doing some of these ourselves. Rotations can be a lot trickier than just translations or reflections. So I'll show you a couple tricks that might help. But let's say I want to rotate this quadrilateral 180 degrees about the origin. So this is my center of rotation, and I'm going to rotate this shape basically to this other quadrant. One way you can do this is, it's actually pretty straightforward if they're right on an axis. Like if this is the point V and I rotate it 180, it's pretty clearly going to be on the other side of that, because a 180-degree rotation is pretty simple. With J, it's also pretty easy because it's just kind of right across there. But these might be a little trickier. And so one tip, and the way I like to do these, is when you are rotating, you can literally rotate your paper. So like put your pencil there to hold the center of rotation and rotate it 90 and then another 90. And now what you want to do is pretend that this is the regular y-axis and that's the regular x-axis, and pretend that these are the points that you want. So notice that V should be at -2, 0. So when I rotate back, I'm going to put V at -2, 0, which I already had. And if I rotate 180, and again, pretend that this is the regular coordinate grid, Y is going to be at -1, 2, 3, 4, up 1, 2, 3. So -4, 3. Flip it back and go to -4, 3. And that's where Y prime should be. Kind of cool trick, right? Same thing with R. Well, it's pretty easy to figure it out from here. R should just be 1 over. So you could just go 1 over. And there's our shape. That looks kind of weird. Let's make sure. R, if we rotate it 180, R should be at -1, 2, 3, 4, up 1, 2, 3. I think I got Y wrong. Y should have been at 5, sorry. I missed one. R was at -4, 3. Y was at -5, 3. There we go. There's my new shape. Just to check J as well. J, if we rotate it, is at -1, 1. So rotate back, -1, 1. There's J prime. One other tool that I'm going to give you to do these is some plastic plates. If you guys at home want to make your own, you can. I lined up the arrows so you know how to kind of match them up. But basically what you can do is put the center of the plates right in the center of the center of rotation. And if you want, you could even draw the axes. And then you can use an expo marker to draw out your shape like this. And then you can literally rotate it. So there's one 90-degree turn and another 90-degree turn. And look, I got it right. Sometimes it can be kind of hard with the small stuff, but you can at least check your work that way.